Hey guys, I'm gonna run through the 3.8 notes. Yes, this is the Alex. Alex problems. This is what your homework's gonna look like. This is what we're gonna cover in class. So, for question 1, we have a graph. So here's a graph of the function f. Use the graph to find the following. If there's more than one answer, separate them with commas. So, all values of f has all values at which f has a local minimum. So what is a local minimum? So we know that from graphing parabolas or quadratics from a couple units before, that a minimum is just whenever you have the lowest point of the function. So all values at which f has a local minimum and all local minimum values. So looking at this graph right here, a local minimum is not necessarily the lowest point on the graph, which would be right here. So this would be considered a local minimum, but this is also not just a local minimum, it's actually an absolute minimum. But it doesn't really ask for that, but it's a local minimum, also an absolute minimum. But there is also another local minimum, and that is right here. So this is another local minimum. All right, so it's a local minimum, and this, even though it's not the absolute, it's not the lowest part of the graph, it's the lowest part of the graph in the nearest kind of immediate vicinity of the graph right here. So all other values of the graph, they are increasing and they're above that point right there. So I guess just basically a local minimum is kind of like it's whenever the point goes from decreasing to increasing. Anytime that the graph will have a sort of characteristic of decreasing then switching to increasing, it creates a local minimum. And so it does that here as well. So it's a point on the graph that where it goes from decreasing to increasing. So there's two values that go into this point right here. So this right here is the point of -3, that's the x value, and the y value is 1, while this one over here has the x value is 4, and the y value is -2. And so this can answer both parts of the question. So all values at, that means, so all values at which f has a local minimum, so this is the x values. So at what x values does f have a local minimum? So for this one, I would say at -3 and 4. And then it says all local minimum values. So this is what the y values are. So the y values are 1 and -2. So I would say 1 and -2 for the answer there. For 2, it's a similar question. So all local maximum values, and at which values of x do they occur? So how many local maximums do I have? So I have a local maximum here. So again, a maximum will be the opposite, where it changes from increasing to decreasing. So here's a local maximum and here's a local maximum. The point here is -2, 4, and the point here is 2, 4. So when it says down here, at which values of x, so that's going to be at x equals -2 and x equals 2. So again, the x values. And what is the actual maximum value, local maximum values? That is 4. And since they both have the same y value, then I only need to write it once. But yeah, that's local minimums and maximums. For 3, it says 4 functions are given below. 4 functions are given below. Yeah, either the function is defined explicitly or as a graph, and decide whether the function is even, odd, or neither. So a function that is even, so a function that is even will have the characteristic of being symmetrical across the y-axis. So we'll say, is that 2 m's for symmetrical, or is it 1 m? Symmetrical, I don't really know. Symmetrical about the y-axis. And so if I look at these functions, so this, it gives you graphs of 2. So you have 2 functions that are given as graph, but then you also have the equations of 2 others. They're not all the same, so they shouldn't be duplicates. So that's what an even function is. An odd function is, this one's kind of weird. An odd function is symmetrical about the line of y equals x. So basically, if you were to take the graph, so let me graph the line y equals x. So this is the line y equals x. So if it's symmetrical about that right there, so if you can take this graph and mirror it across right there, then it should be the same, it should be symmetrical. Another way, I think that's what an odd function is. I think that's correct, or I might be thinking of something different. I'm going to come back to that, but I think that's right. And a function that is neither of them just means that it's neither symmetrical about the y-axis or the line y is equal to x. And then how can you tell that from just the equation? So from the equations, if a function is even, then that would mean that if you take the function and it will be equal to f of negative x. So this is like your proof. So how do you prove algebraically if a function is even? Well, if you substitute negative x into the function for x and you simplify and they become the same function, then it's even. Symmetrical, or for an odd function, then if this one, you'd have to show that f of negative x is equal to negative f of x. So if you can prove this right here, then the function will be odd. And if neither of these can be proven, then it's neither. Okay, so for, I'm going to just double check 1 second here. I'm going to Google it. Are odd functions symmetrical? Oh, it does need 2 m's. Symmetrical about the line y equals x. Let me verify if that's true. Yes. Yeah, so it is symmetrical about the line y equals x. So this graph right here, if you were to reflect this part of the function, or I guess this part doesn't really matter, if you reflect either part of the function over this line right here, then it's odd. So in this case, it is true that this is symmetrical about this line right here. And so this is an odd function. For this function right here, so it definitely won't be an odd function. It's not symmetrical about the line y equals x, but it is symmetrical about the y-axis. So it's symmetrical about the y-axis, which means that this function is even. Okay, so if you have a graph, you should be able to tell if it's even or odd by looking at it, or neither. And then for these functions right here, where it's given to us as the equations, what we're going to have to do is, so what I like to do is go through this process. I first check to see if it's even, and then I'll check to see if it's odd. So if I take the function and I substitute negative x into the function, do I get the same thing? So another helpful hint for you guys whenever you guys are simplifying these. So let's just say this: if the degree is even, and I'm talking about the degree of each term. So if I'm looking at this one right here, so if the degree is even, then negative x plugged in for it will not change anything. Will not change the term. But if the degree is odd, then negative x will change the sign. It will change the sign of the term. And if there's no x, then there's no change. So take a look right here. Well, I guess we're not checking for, are we checking for, negative x squared. So if I were to, so I have g of x, and I know that g of x is equal to negative 4x to the fifth and 5x to the third, but what is g of negative x equal to? So g of negative x, well, if I'm plugging in negative x into an odd degree term, so this is odd, it's going to flip the sign. So this right here, when I plug in negative x, is actually going to change it to 4x to the fifth. And if I plug in negative x here, then this right here is going to be negative 5x to the third, because it's an odd degree. Okay, so is it even? So is this equal to this? Are they the same? They're not. So that means it is not an even function. So this function is not even. And now I check to see if it's odd. So I already have this part, I already have this part because I checked it here. So does this, so the function I have here, equal negative f of x? So what is negative g of x? And for negative g of x, what does that do to this function is it flips the signs of every term. And so I will write this one as positive 4x to the fifth minus 5x cubed. So this is negative g of x, this is g of negative x. Are these equal to each other? And if you look at them, they are. So this function right here is odd because reflections over the x and reflections over the y are the same, meaning that it will be symmetrical about the line y equals x. So for the next one, so again, the first thing I like to check is the negative x inside. So if I have an odd degree, that's going to flip the sign of the term. So that's going to be 4x to the fifth. If you're plugging in negative x into an even degree, so into an even degree, it does not change the sign of the term. So this one will stay 5x squared. So are these the same? So is h of x equal to h of negative x? No, this is negative and this is positive. So they're not the same. So then I go ahead and I check negative h of x, which flips the signs of every term. So that will be positive, that will be negative. So I'm going to have 4x to the fifth minus 5x squared. And then I see if these are the same. And they're not, because this is positive and this is negative. So because neither of these were equal to each other, that means it's neither. So this is a neither. Okay, let's check this one right here. So is the function even or odd? So if I take a look at this one, it's pretty obvious that this is symmetrical about the line y equals x. So this is even. For this one right here, definitely not symmetrical about the line right here, and it's not going to be symmetrical about the line y equals x. Look how it's very off-centered right here and not based off of the origin. So this one would be neither. So it's not symmetrical about either of those two lines. Okay. All right, now for this one, so I'll check to see if it's even. So I know g of x, so let me see what g of negative x is. So g of negative x, if I plug in negative x into an odd degree, it's going to flip the sign. So it's going to be 4x to the fifth. If I plug in negative x in here, that's going to flip the sign. So that's going to be negative 3x to the third. So these are not the same, so it's not even. So now I'm going to check if negative g of x is equal to g of negative x. Negative g of x is going to flip the signs of both. So it's going to be 4x to the 5th minus 3x cubed. And if these are the same, then it's odd. And these are the same, so this is odd. All right, for the next one, so I'm first going to check g of negative x. So g of negative x, if I plug it in, will if it's an even degree, it won't flip the sign. So I have an even degree, so this stays 3x squared. And I can see that this is still the same thing right here, and I guess I don't know why I used g. I should have used h, but whatever. So because these are the same, it's even, and I don't need to check if it's odd. Okay. For question 5, so consider the following polynomials. So we have two polynomials, we've got f and we've got g. Choose the graph of each function from the choices below. So starting with f, so we have 6 functions right here, and this one belongs to one of these 6, and so does this one. So 4 of these graphs are just not at all 4 of these graphs don't belong to f or h. And so when I'm checking out what this is right here, the first thing that's helpful is something that we learned from at the beginning of chapter 3, which is the leading term. So the leading term has a negative leading coefficient and an even degree, which means if you're measuring if you're looking at the left end of the function and the right end of the function, well, the left has to go down, and so does the right. So if it's an even degree, they both have to go in the same direction, either rise on the left and rise on the right, or it falls on the left and falls on the right. And because it's a negative leading coefficient, it's going to be falling. And so I can tell you that A is not going to be F. I can tell you that D isn't either. It could be B. It could be E. It's not going to be C, and it's not going to be F. And so f of x is either going to be this one or this one right here. So which one is it? So the next thing what I'll do is, let's see if I can eliminate, I was going to say look for y-intercepts. So this y-intercept is 0, because if you plug in 0 for x, so to check for y-intercepts, you plug in 0 for x, and if you plug in 0 for x, you just get 0. But these both have a y-intercept of 0, so that doesn't help. The next thing I'm going to check for are x-intercepts. So maybe I can factor this, so I can factor out, factor out a negative 6x to the third. And if I factor out a negative 6x to the third, I'm going to get x plus or x minus 2, right? So x to the third, yeah, I think that's right, because that would become negative 6x to the fourth, and that would become positive 12x to the third. So I can tell you here, so to find the x-intercepts, you set y equal to 0. So, and if it's equal to 0, you can set both of these equal to 0. So if you have x to the third equal to 0, that just simplifies to be x equals 0. But then if you have x minus 2 equals 0, you can solve that to be x is equal to 2. So these are my x-intercepts for that graph right there. So which of these two graphs have x-intercepts at 0 and at 2? So at 0 and at 2, so there you go. This right here has to be the graph of f of x. And so this one is going to be graph B. Graph B for that one. All right, for h of x then. So for h of x, which of these belong to h of x? So first thing I'm going to do is think about the leading term. But because this one's factored, I have to add up all the degrees of the factors. So this factor is of degree 2, while this factor is of degree 1. So this one has a degree of 3, and it has a leading coefficient of negative 4. You can see that out there. So the leading coefficient is equal to negative 4. All right, so then if it's an odd degree, that means on the left it has to fall and on the right it has to rise, or opposite. So left it has to rise and left it has to fall. That's if it's a degree 3. If it's negative, then on the left it has to go up and on the right it has to go down. So that's graph A and graph D. All right, it's not going to be graph B or graph E since both are going down, and it's not going to be graph C since both are going up, and it's not going to be graph F because on the left it's going down and on the right it's going up. So it's got to be graph A or it's got to be graph D. Now, you can check for y-intercepts. Yeah, you can check for y-intercepts, or actually I'm just going to check for x-intercepts since this is already factored. So what are the x-intercepts? Since I have x minus 1 squared, if I solve x minus 1 equal to 0, that means x is equal to 1. And if I check x minus 3 equal to 0, that means x is equal to 3. Those are the only x-intercepts. This one has another one at -2, so it's not going to be D. Another thing to know is that because x equals 1, it comes from a factor that is being squared. So because this factor happens an even amount of times, then that means that at x equals 1, the x-intercept doesn't cross, it should only touch. So you can see that right here. At x equals 1, it only touches, and that is confirmed by the number of times this is. So if it's an even amount, if you have a factor that is an even amount, then that x-intercept shouldn't cross, it should only touch. So like right here, x equals 3, we only have one factor, which is odd, which means it should cross through the x-axis at that x-intercept. So this has got to be graph A. So graph A is h of x. Okay, let's try 6. So 6 is very similar. So we have g of x, we have h of x, we have these 6 graphs right here. So let's look for g of x. So g of x is in standard form, not factored form, just like the other one, where it gave us one that was in standard and one that was factored. So I'm going to look at the leading degree. So it's negative leading coefficient, odd degree, which means on the left it has to go up, on the right it has to go down. So it can't be A. It could be B. It can't be E, can't be C, and it can't be F. So our two choices are between D and B. So the next thing I like to do is I like to see if y-intercepts will matter. So, because that's just easy for y-intercepts. So for y-intercepts, if you make x equal to 0. So if I make x equal to 0, every term has an x in it, which would mean every term would become 0. So I should have a y-intercept at 0. The y-intercept for graph B is not at 0, but it is for D. So I'm going to say that D has to go for this one right here. So this is graph D. All right, for h of x is equal to 3, x minus 2 squared, x plus 1 squared. So if I count the degrees, it's squared. This factor is squared, this factor is squared. And if I add the degrees, I can tell you that the degree here, the degree is 4, and the leading coefficient is 3. So it's positive. So degree 4, which is even, leading coefficient is positive, so both ends have to be going up. So it's not A since both ends are going down, it's not D, it's not B, it's not E, so it's either C or F since both of these ends are going up on the left and on the right. The next thing I'll do for this one, because it's factored, is look for the x-intercepts. So this one has an x-intercept at 2 and an x-intercept at -1, and because these are even factors, or the degrees are even, they should bounce off of it or just touch the x-axis. So at 2 and at -1. So both here, so at 2 and at -1, these ones cross. So it's not going to be C, it's going to be F, and you can see here that it bounces at -1 and bounces at 2 or touches, and so this one's got to be graph F. So graph F for this one. And there you go. Okay? All right, and for question 7, so below is the graph of the polynomial function with real coefficients. All local extrema of the function are shown in the graph. Use the graph to answer the following questions. Over which intervals is the function decreasing? So I'm going to highlight the intervals where it's decreasing. So, or I'll highlight the graph in red where it's decreasing. So here I can tell you, if I trace it in red, this is where it's decreasing. Here is also where it's decreasing. So it's where the y values are decreasing. So here the y value is like somewhere between 4 and 5, and then it keeps going down until the y values become -1. And the same thing happens here. So the y values are 4 and the y values decrease to 2. So decreasing, decreasing. The other intervals are where it's increasing. Okay, so increasing, increasing, and increasing when you read the graph left to right. Now, what are the x values? So these intervals right here, or these parentheses, they're not coordinate points. They're saying from x equals -7 to x equals -3, or x equals -2 to -3 to x equals 2. So this is called interval notation, intervals. And so when I go here, since here is where it begins, I go and look at the x-axis for those points right here, the x values, and I shade in between them. So shading kind of helps me get these down a little bit. So in between here, this right here is the interval. So what is this interval right here? It's between -7 and this right here is -3. So this is the interval where it's decreasing. So I would check mark that one right there. And the other one, so if I look at the other interval, so here to here, if I look at the x values, that is going to be between 2 and 5, it looks like. So between 2 and 5 is where it's also decreasing. So between 2 and 5, so right there, those are the intervals that it is decreasing. For B, at which values does the function have local extrema? So local extrema meaning that could be local minimum or maximum. So what are the x values? So if I go back to the graph right here, so here is a local maximum, local minimum, local maximum, local minimum. So the x values are at -7, at -3, at 2, and at 5. So it's asking for the x values. And so we would put, whoops, I totally read that wrong. Not local extrema. This is just local maximum. Sorry. So the local maximums, if I correct myself here, let me erase all that right there. So the local maximums are here and here. So what are those x values? So that's at x equals -7 and at x equals 2. So you would say here, so x equals, I'm not sure what it looks like on your end, but x equals -7 and x equals 2. What is the sign of the function's leading coefficient? Positive, negative, or not enough information? So if I remember just basically how I identified these graphs from above, so I can see that's going down on the left and up on the right, which means it's an odd degree. But because it's an odd degree and going down on the left and up on the right, that means the leading coefficient has to be positive. Okay, so that's just information that we got from the previous chapter. Which of the following is possibly a degree for the function? So what could be the degree? Well, I know that the degree has to be odd, so I know it can't be 5, 6, or 8. And now we don't know for sure what the degree is, only that it's odd. And then we can also state like what it could possibly be. Now, there's something called the turning point. So turning points. So how many turning points does this graph have? Meaning how many times does it change from increasing to decreasing or decreasing to increasing. So that's basically turning points is like the total number of minimums and maximums. So here's one turning point, here's another turning point, here's another, and here's another. So I have 1, 2, 3, and 4 turning points, which means that the absolute, that the degree of this function has to be at least 1 degree greater than this right here. So the minimum degree of this function is 5. It has to be one more than the number of turning points that it has. And so if I go down here, 5, could this be a degree 5? Yes, it could be a degree of 5. Could it be a degree of 7? It could be. Or a degree 9? It could be. So it's either 5, 7, or 9. Or it could be even 11, so on and so forth. But all right, for 8, very similar, just asking the same things. So for 8, it's asking for intervals where the function is increasing. So going left to right, it goes up here. So this is an increasing interval, and this is an increasing interval right here. So what are the intervals here? So this one, if you consider that it doesn't necessarily have a left endpoint because this keeps going down. So the function is actually increasing all the time from the left side up until it gets to this point right here. And so that would mean that it would be increasing from the x value, so as far left as you can go, which we call negative infinity, all the way to -8. So again, if you kind of look at the x-axis, so I'll highlight here. Now this keeps highlighting, I can keep highlighting to the left, meaning it's going to negative infinity, but from negative infinity up until the x value of -8, it is increasing. So there, and then here, if I look at the next interval, that's starting from -1 to 5. So -1 to 5 is the other interval. So -1 to 5. Okay. At which x values does the function have local maximum? So local maximum would be here. So that's going to be at x equals -8. And here, and that's going to be at x equals 5. So -8 and 5. What is the sign of the function's leading coefficient? So I have an even degree. It's definitely even because it's going down on both sides. And because it's going down on both sides and not up on both sides, it's a negative leading coefficient. So this is negative. Which of the following is a possibility for the degree of the function? Well, like we said before, it can't be odd. It is an even degree. So it can't be 5, 7, or 9. Now I'm going to count the number of turning points. So turning points, I've got 3. So I've got 1 turning point, here's a second, and here's a third. And so the degree has to be at least 1 more than that, which would be 4. So that's the lowest possible that it could be. So it could be 4, it could be 6, and it could be 8. Okay? All right, for 9, it says use a graphing calculator to find all the zeros of the polynomial function round to the nearest hundredths. So this means right here, so round to 2 decimal places. So decimal places. And yeah, as far as graphing calculator, there is one in ALEKS, but it's kind of hard to use. So I would just recommend that you use Desmos. So I'm going to go to Desmos. All right, and I'm going to plug in the function. So I have 2x to the 4th plus x to the 3rd minus 6x squared minus 2x plus 1. So I've got 4 x-intercepts. I think that's what it wanted us to find. It wanted us to find the x-intercept. So from left to right, and if I'm rounding to 2 decimal places, so that's going to be negative 1.78. So negative 1.78. And then the next one would be negative 0.62 if I'm rounding to 2 decimal places. The next one will be 0.28, and the next one will be 1.62. So that's what I'll put into my answers here. So find all the zeros. So I'm going to have x is equal to negative 1.78, negative 0.62, 0.28, and 1.62. For 10, use a graphing calculator. So same thing, find all the zeros, round to the nearest tenth. And so I'll go into Desmos right here, and I'm going to type in the function. So the function is negative 2 x to the third minus 2x squared minus 2x squared plus 8x plus 3. So I've got those 3 x-intercepts. So negative 2.40, negative 0.35, and 1.7, negative 1.76. So there you go. So I would type in x is equal to negative 2.40. Make sure that you do include 0 if that is indeed the second decimal place. It might mark you wrong even if you don't have it, which is kind of ridiculous. So negative 0.35 and then 1.76. All right, for 11 and 12, use the polynomial function g. So we have a polynomial function g, and use a graphing calculator to find all the points where it has a local minimum. So local minimum, so let's go ahead and graph it, and we'll see where it has local minimum. So I'm going to put it into Desmos. So I've got 4 x to the fourth plus 3 x to the third minus 9x squared plus x and plus 6. So local minimums, I see 2. So the first one is down here. So it wants the point. So this point right here being negative 1 point, I guess I would round that to negative 4.0. And then the y value is negative 5.90, negative 5.91. And then the other minimum would be this point right here. So 0.78, and the y value being 4.21. So that's what I'll put into the ALEKS. So I'm going to have 2 points. So the first point was negative 1.40 and negative 5.91. And the other point was 0.78 and 4.21. Okay, and then for 12, all right, so we're going to put that into Desmos. So I got negative 2x to the fourth, so negative 2x to the fourth. There we go. So negative 2x to the fourth, and then plus 3x to the third. Whoops, 3x to the third. And then plus 5x squared minus x minus 5. And then are we looking for minimums or maximums? So maximums is what we're looking for. So I see 2 maximums. So here's this one all the way up here. So that is going to be at the point 1.7, 1.79 and 5.90. The other maximum is right here. Whoops. Other maximums right there. So negative 0.75 and negative 3.34. So for maximums, negative 0.75, negative 3.34, and 1.79, 5.90. So those are the local maximums. And that is everything that you should know for this homework assignment. So good luck, and let me know if you have any questions.